Okay, Jia. So we are preparing IGCSE Computer Science syllabus, and quickly we are revising all the chapters. In your paper 1, you will have 6 chapters. So instead of writing, I am showing. We have 6 chapters: data representation, data transmission, hardware, software, internet and its uses, automated and emerging technologies. Okay. Now, this chapter, the weightage is like 20 marks to 22 marker questions can come from this chapter. So first priority is data representation. Okay. Second priority, the internet and its uses. Again, this chapter is very important. 15 to 20 marker questions can come from this chapter. Okay.
Yeah.
And this is the priority. So we have chapter 1, chapter 5, we have chapter 1, chapter 3, and chapter 5 on high priority. Okay, we should know each and everything about these 3 chapters, because I think 60% paper or 60 to 70% paper will be based on these 3 chapters. Okay. And we will try that we will cover from everything from this Hodder publication book. Plus we have another book, Cambridge University Press. So we will check what things, like what other language or what other note this book is providing, right?
Yeah.
Okay. So these 3 chapters are important. You should note down. Then after that, so just 1 minute. This chapter, and this chapter on high priority. High priority. Then after that, or I'm writing number. First, although they are equally important, first, second, third. Then fourth priority is to data transmission. Then fifth priority is chapter 4 software. And then sixth priority is chapter 6, because from chapter 6, they will ask you 5 to 9 marker question.
Okay, so
From
not
chapter 6, right? Chapter 6, like you can do tomorrow, like last moment, you just need to learn characteristics. I will tell you how you will prepare, but very least priority, but 100% one question will definitely come, but 5 to 9 marker. Okay. Chapters from chapter 4, all the languages, IDE, operating system. These topics are very important. Okay. So from chapter 4 again, 7 to 12 marker can come from chapter 4.
okay.
Chapter 2 is important because what is happening in paper, sometimes they are interchanging priority of chapter 2 and chapter 5. So chapter 5 can come of like 15 to 20 marker, but maybe this time it will not come. Maybe they will give priority to chapter 2. So chapter 2 is equally important.
Okay, so I'll do that.
Yes. So this is the summary. And we are starting from chapter 5 because chapter 1 is not very tough and we can do it later also. Okay.
Yeah.
So we should start the revision, or you tell me chapter 1 or chapter 5?
Chapter, can we do,
Chapter wise?
yeah, can we do start from the beginning and just do
Right.
like a
So
little
we are
bit?
doing this chapter first. Then we will do chapter 3, because you know what? We have to do very smart study from chapter 3. In chapter 3, again, please note down. In chapter 3, you will read each and everything from von Neumann architecture. Von Neumann architecture is itself is very important. It will come off 10 marks. Then this is the first topic. Second topic from chapter 3 is storage, all kind of storage, hard disk, SSD, RAM, ROM, DVD, CD, and cloud. Cloud is very important. Cloud storage. Characteristics, advantage, disadvantage, everything. Okay. Then sensor based questions, like sensor based question are important from chapter 3. So chapter 3 is basically these three topics are important. From input and output devices, they can just ask you like maximum 5 marker question, maximum 3 to 5 marker question from input and the output device, and in a very simple manner. Like they can give you some scenario, like in mobile phone, which tell me any two device, input device, tell me any two output device. Maybe in the washing machine embedded system, like what two input devices we can use, what two output devices you can use. In the microwave oven, what two input devices and output devices. Okay, otherwise fill fine. So this thing. And one important question from this chapter 3 is network hardware. Every year IPv4 and IPv6 characteristic, MAC address, router, these are important. Okay, so let's go one by one. So we are doing chapter 1, quick revision. Whenever you will prepare yourself for exam, you must have this syllabus in hand. Okay, so you will not, whatever you are reading from any book or any past paper, you have to ensure that you are covering each and every topic from the syllabus. And if in case if in case they are already providing you some notes, then you have to give priority to this language, because in answer key this language will be there. For example, understand the concept of overflow. So if they are asking what is overflow, you will write it's occur if the value is greater than 255. Okay, so these are the limited notes they are providing in syllabus, and you will give priority to this. Okay. Okay.
Yeah.
Let's set target. It is 6:15. 6:45 we will wind up this chapter. Okay.
Yeah.
Okay. How and why computer uses binary to represent all forms of data? Why computer understand binary? Quickly tell me.
Okay, computer has an on-off system,
Mm-hmm.
and binary, like 0 represents off and 1 represents on.
Right. Okay. Computer is made up of lots of switches which are based on and off concept. On means 1, off means 0. Okay. Okay.
Yes, yes.
Okay, just 1 minute. I'm finding time. So I have started timer because not 45 minutes, in fact, 30 minutes. In 30 minutes, we have to finish this paper 1 revision. Okay. We will solve one question each, and you will tell me the way of writing, because most of the time they will not ask you that you will convert denary into binary by using this method only. IGCSE will not ask this. Okay, IGCSE never asks these type of things where they are saying, okay, you have to follow this method. I don't think. Okay.
Yeah, okay.
Okay. Now, let's say denary number is 56. This is a denary number. And we have to convert into binary. What should I do?
So you should write out the powers of 2.
Okay, so this means 2 raised to power 0 means 1.
1, and then 2 raised to the power 1, and then you write it until, because it's 52, so you don't need to write it past wait.
Okay,
So
one important thing. In your syllabus, you have only 8-bit register for this type of conversion. Okay, so we will solve only 8-bit questions. Maybe in hexadecimal, they can give you like big question, but here 8-bit register. So
Okay.
1, 2, 4, 8, 16, 32, 64, 128, right?
Yeah.
Yeah, create making this box. This is for 128. Okay, now tell me what should I do?
Now basically
Hmm?
you have to do basically align. So if so for example 56, so 56 128 is bigger than 56, so 0, then 0 because 64 is bigger than 1, and then you subtract 1 from
Not
30.
subtract, not subtract, we are adding. 32 plus 16 is 48. And 48 is in the range of 56. So we are taking 1 in both the numbers.
And then 6 and then 8 will just become 56. So you just put another 1
So do I put 8, 1 here?
and then 0, 0, 0.
Okay. 48 plus 8 is 56 and then 0, 0, 0. Okay.
Yeah.
So, and again, I'm telling you, Gia, most of the time, students who are getting full marks in whole these 2 years of IGCSE, sometimes not getting marks in board exam because just because of last moment panic, just because of exam fear. So again, I'm telling you, once you will attempt number system question in your IGCSE board exam, after finishing your paper you will carefully recalculate all the calculations. Okay, this is like highly advisable.
Okay.
90% students, we are deducting marks of 90% student just because of silly mistakes. Sometimes they are using 0, 1 here. Okay,
Yeah.
and you know what is a common mistake? We are giving you number in hexadecimal. Okay, so if I'm giving you number in hexadecimal, let's say 68, and in question, in the given scenario, I'm telling you this is hexadecimal, and then I'm asking you have to convert it into binary. Then what students are thinking ki, okay, this is maybe denary. They are not reading that this is hexadecimal number, and it is very valid hexadecimal number, because hexadecimal number means 0 to 9 and then A to F.
Yeah.
So you have to carefully check the scenario. You have to ensure that what kind of number it is and what kind of conversion they are asking. Okay.
All right. Yeah.
So this is done. Now denary to binary done. Let's do denary to hexa. How you will solve denary to hexadecimal? You tell me, what should I write? The number
Convert
is again
D.
56.
So you convert it to binary.
So what was the binary? 0, 0, 1, 1,
1
1,
1 1 0 0 0.
0, 0, 0. Now what
So
will do?
you divide it into two parts, four per part, and then you solve it, but it'll
From
be
where
8
I should start making group, from your
from
right
the
side or
beginning,
left side?
from the right side.
From
So
here.
you make the
Okay.
first group of 4, and then that becomes 8, and then
That
this
becomes
group
8
of
because 1, 2, 4, 8. So this is 8. Then
and
again, this is another group then. 1, 2,
1 and
4.
2. So 3, 38.
So 38, the corresponding hexadecimal number of 56 denary. Okay. Fine.
Yeah.
Now, so denary to binary, denary to hexa done. Now binary. Binary to denary. I'm giving you this number 0, 1, 1, 0, 0. Okay. Quickly tell me the denary equivalent of this.
Okay, so um
I'm writing numbers. Way. So what is this way? 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 3, 2 raised to power 4, 2 raised to power 5, 6, and oh, oh, oh. Okay, again I'm writing what was the binary. Okay, let's do it. 0, 1, 0, 1, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. Let's say this is the binary. Now tell me, you just tell me what should I add. We are not adding it. We are not calculating. Just tell me the formula.
okay, so you add so you basically add up the first, like 2 to the power of 0
Mm-hmm. So what?
plus,
Okay,
so
fine.
1 plus
Mm-hmm.
um plus what is 4
Mm-hmm.
plus
Okay, so
6
I'm writing like this way. 1 plus 4 plus
plus 16
hmm,
plus 64.
Okay, and then you will calculate it. Let me check. 1,
Yeah.
2, 4, 8, 16, 32, 64, 128. Every time 1 means 2 raised to power 0, 2 means 2 raised to power 1, and so on. And we are adding only those number where bit is 1. Okay, so this is also done. So this was binary to denary. Now this is the binary 101101111111. In this case, they can give you 12-bit answer where they are asking you have to convert this binary into corresponding hexadecimal. Now what we will do? I think we did it already.
Yeah. So basically, okay, then you just have to do the same thing, but you just have to do it into groups of four and find the hexa. It's
Right.
not.
So what is the final answer? What we will do in this case if there are only 3 bits left? You are starting making groups
You
on
just
the
make
right.
the zero at the.
As a most significant bit, or at the left as a leftmost bit. Or if we have only 2 bits at the left side, we can add 2 more
2 0.
to make it 4 bit. Now what
Yeah.
is the answer? 1111 1248. What it means?
So this means hold on, 15. So that's just E.
That's F.
F, sorry. Yes, miss. I remember. I'll write them all. I'll write them all.
B11, C12, D means 13, E means 14, and F means 15. So this is F. What is this 1011?
That's
Again,
8
1248, huh?
8 plus, wait, hold on. It's 11. So that's just B.
That's just B. Okay. What is this? The 0101.
0 1
0101.
0 1. That would be 4 plus 1, 5.
5. So
5
the final
B.
answer is 5BF.
Mm-hmm.
Okay. 5 best friend. Okay. So 0101, 1011, 1111. From the rightmost side, we are making group of 4 bits. Why 4 bits? Because hexadecimal number system base is 16. Why 16? Because it is made up of 0 to 9 digits, total 10, and then A to F 16. So 16 can be represented as a 2 raised to power 4, and whatever power you are applying on 2, this number 4 is representing number of bits.
Okay.
Okay.
Yeah.
Okay. So this is also done. Now hexadecimal number 2AC. What is the binary of 2AC?
Okay, 2AC. So first you start with C and you make it binary.
Hmm. 2AC
Yeah,
first. Huh?
2AC. So C you make it binary first. So C is basically just 12. So
Hmm.
it'll be
And
8. So 1100.
1 1
And then
0 0. Okay.
this one 10 will just be 1010.
Just 1010. And what is
Yeah.
this 2?
And then 2 is just gonna be 0010.
0010. Okay. So the final answer is 0010 1010 1100. This is the final answer. Okay.
Mm-hmm.
Okay, so whatever number they are giving you, you will make a like you will show each digit with a 4-digit binary, 4 binaries.
All right.
Okay. Now hexa number, let's say DF. How you will convert DF into denary? You just tell me verbally what you will do.
Okay, so denary, so hold on. So you first convert it into binary and then to denary.
So what is the corresponding binary of D and F? F
Okay,
is
so is
15,
1111.
right? F is 1111.
And then denary, the D is just hold on. One, wait, no, yeah, one,
Hmm?
one, one, wait, and then 10.
So 3 times 1 and 0?
Yeah.
Okay. So 1, 2, 4, 8, 12, 13, 14. No. Are you sure? What is the binary of D?
Wait, the binary of D is 13.
13, right? So
Also 1101.
right, 1101, right? So this
Yeah.
is the binary of D. Now what we will do, because we are converting this hexadecimal number, it's a hexadecimal number. We have to convert it into denary. So first we are converting it to binary, then we will solve it all together. So starting from the rightmost side, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. Okay, so this means we are adding only those bits where we have bit 1. So 128 plus 64 plus 16 plus 8 plus 4 plus 2 plus 1, right?
Yeah.
So we will add them, all of these numbers, and then we will get the final answer. They will not give you calculator, so you have to be like fast while solving these questions. Calculators not allowed in IGCSE board.
Yeah, it's not, yeah.
Now, so this part is done. Denary is a base 10. Can you tell me why denary is a base 10?
Because base 10 system is the normal system, right?
What is
No, like
normal?
it goes up to 10. See, it has 10 digits, like 0, 1, 2, 3, 4, 5, 6,
Yes, it is
7,
based
8.
on 0 to 9 digits, and these are in total 10. That's why denary base system is 10. Why binary base is 2?
Because it has only 0 and 1, which is 2
2 digits.
digits.
Hexadecimal, we already discussed. Values used will be integers only. Okay, so they will show you. So we discussed this thing. Conversion in both direction, denary to binary, binary to denary. Maximum binary number length of 16-bit. 16-bit number they can give you, but for hexadecimal case. Okay.
Okay. Yeah.
Areas within, but you know this thing, whether they are giving you 16-bit, 20-bit, you just need to make a group of 4 bits, right? And you can do this.
Yeah.
Okay. Now, this question is quite popular. How and why is, okay, why hexadecimal number system is beneficial method of data representation? Like, or they can ask, what are the benefits of representing data into hexadecimal? What will you?
Less storage space. It's harder to make errors because there's less digits being used.
Less digits. Okay, so we can,
And it's also
okay,
compatible with all of the computer systems.
it is compact than binary. Then to support our answer, you will write how many bits. 4 bits are represented by only one hexadecimal. 4 bits
Yeah.
represented by only one hexa, right? So it is
Yeah.
compact. So if it is compact, and you know what, it is not about storage, that it is taking very less memory, like it is taking very less space on screen. Okay, so taking less space on screen, that's why, then you will support this point, that's why it is easy to understand and read. Okay,
Yeah.
so understand how and why hexadecimal used and how it is beneficial. Let's see. Hexadecimal is easier for human to understand as it is shorter representation of the binary. So we are writing the same point. Okay, now
Yeah.
everything where we are using application. Quickly tell me the application of hexadecimal, where we are using hexadecimal number system.
Okay, so hexadecimal number system is used in most like modern like
Error codes, do you remember?
error codes. Oh yeah, error codes, IP addresses.
Right, IPv6. IPv6
These-
address are represented by hexadecimal. MAC address also represented by hexadecimal numbers. Okay,
those all of those like
HTML color codes,
yeah, HTML codes and I remember one more. There's the
memory dumps.
no
No,
yeah no yeah that.
I think you have another example in your mind. So you can tell me later. Okay.
thinking, but I've forgotten it now, I think.
But
Yeah.
it's okay, Jia. This question will come of maximum of 2 marks or 3 marks. So you
Okay.
have three examples in IPv6 address, in MAC address. HTML color codes are also represented by hexadecimal. Okay?
Yeah.
Okay. So this is done. This is very common question in IGCSE. Now let's come to the binary addition. This question can also come of 3 marks or 4 marks. If it is coming of 3 marks, we have to show carry. Okay. Showing carry is very, very important. Quickly tell me the rules of binary addition. 0 plus 0,
0 plus 0 will be 0.
0 plus 1,
0 plus 1 is 1.
1 plus 0,
1 plus 0 is also 1.
1 plus 1
1 plus 1 is 0 with a 1 carried over.
with carry 1. Okay. Now quickly tell me the answer. 0 1 0 1 1 0 1 2 3 4 5 6 7 8. Then 0 1 1 0 0 0 1 0. Tell me the answer. Plus.
Okay. So start 0 0 0.
Start from the rightmost side. So
So
0
yeah, so
plus 0
0.
0. Okay.
Then 0 here, but carry 1. So it
Okay.
becomes 1 here.
Okay.
Then here is 1 again.
Hmm.
Then this is 1.
Hmm.
And this is 1. Then
Hmm.
this is 0, but you carry 1, so it becomes
1.
1.
Okay. So
Yeah.
if this question is of 3 marks, Gia, most of the time it is of 3 marks. So if you are writing 4-bit, you are getting 1 mark. This 4-bit, 1 mark. You are showing proper carry, 1 mark. Okay.
Okay.
Now tell me the answer. 0 1 1 1 0 1.
Okay, so
Now
it
tell me the
starts
answer.
0. Then this becomes 0 with carry over 1. Then
Hmm.
this will become 1 carry over 1.
Hmm.
Then this will become 0 carry over
This is
0 carry over 1.
0 carry over 1. Hmm.
And then this will become 0 carry over 1,
Hmm.
1 carry over 1,
Hmm.
1 carry over 1, and then 0 carry over 1, and then 1.
Now they will give you two numbers, 8-bit number. You can see 1 2 3 4 5 6 7 8. First input is of 8-bit. Second
Yeah,
input is also of 8-bit. But you
yeah.
can see the final answer. Your final answer is not of 8-bit. It is producing extra bit.
It's an
9-bit.
overflow error.
Right. So this problem is because 1, 2, 3, 4, 5, 6, 7, 8. It is producing extra 1 bit, 9th bit. This is known as overflow error. And
Yeah.
your 8-bit register, what is register? Registers are the small storage space inside the CPU. And if your register can hold, the capacity of register is 8-bit, then how it can it can keep this extra bit? And if it is not keeping, the answer is incorrect. So this problem is overflow error. Okay. So
Yeah.
overflow error will occur if the value is greater than 255. They can ask you this type of question where they will, maybe this will be of 4 marks, 2 marks for showing addition and 2 marks for writing comment. So in your comment, you will write this comment that this answer, this calculation will generate overflow error because it is producing 9th bit, and 8-bit register cannot hold this extra bit because of limited capacity. Okay.
Okay.
So,
Yeah.
and why? So we discussed this also. You can see, like, it is on you what language you will write. Overflow error occur when a value outside the limit should be returned. Okay.
Yeah.
Okay,
Okay.
this is done. Now let's come to this point. Logical left shift. Let's say this is the number. You tell me. 0 0 1 0 1 0 0 1 2 3 4 5 6 7 8. We are shifting 2 bits left. In your syllabus, you have logical left shift and logical right shift. Now, what will be the answer? 1 2 3 4
Yeah.
5 6 7 8.
So
What?
the answer will be
Hmm.
1 0 1 0 0. The rest are just zeros.
Okay. Quickly tell me the denary, corresponding denary of your original binary.
Um, I mean, the final will just be 4 times more, but it'll just be okay. Sorry, the six. This would be 32 plus 8, so 40.
40. So this binary is of number 14. Now, can you tell me the resultant? What is the denary of resultant binary?
Yeah, it'll just be it looks like it's 128 plus 32, so that's 160. So that's correct.
So answer is correct. Why it is correct?
It's 4 times more. 2 times 2 to the power times 2 to the power of 2 more.
2 to the power 2. Why 2 to the power 2? Because this power
Shifted
is
to 8.
representing number of shifts.
Yeah, shifts.
Okay. So logical left shift is used to perform multiplication. And if you are shifting 2 bits, 3 bits, we will multiply the original number by 2 raised to power number of shifts. So this is our answer. So if they will ask you, write the comment. In your comment, you will write this thing that my answer is correct, because the answer is the binary I'm getting as a result is a binary of 160, which is equivalent to 40 into 2 raised to power 2. Okay?
Yeah.
Okay. Now tell me the answer. 1 0 1 0 1 0 1 2 3 4 5 6. Let me take another number. 1 0 0 0 0 1 1 0. 1 bit shifting, 1 bit left shift. Question is, you have to shift this number 1 bit left. Now tell me the resultant binary.
Okay, so it'll be 0 0 0 0 1 1 0 0.
Okay,
But there'll be an error here because one digit was
right.
like
This is error, and why the error?
overflow because one was like removed. One became like the ninth, like it shifted and one like went out. The one of the ones got out.
Right. During shifting, lost 1 bit. That's why answer is incorrect, because this is the binary of 1 2 4 8 16 32 64 128. It's a binary of what number?
128 plus 4 plus 2, so 134.
134. And what answer we are getting? 1248. We are just getting 12. And obviously, what answer we are expecting? 134 into 2. This answer we were expecting. But we are
Yeah.
not getting this answer. Why we are not getting? Because during shifting, whenever you are shifting 1 bit left, you are losing this bit 1. That's why answer is incorrect. Okay?
Yeah.
Okay. Quickly tell me the answer of this. 0 1 0 1 0 1 2 3 4 5 6 7 8. 2 bits right shift. What will be the final resultant binary? 2 bits right shift.
Okay, so 2 with right shift. It'll be 0 0 1
Mm-hmm. 2 bits
0
right
0 0 0 0 0 0 1
0, triple 0, then 1.
0 1
Mm-hmm.
and then 0
2 times 0.
1 2 zeros. Yeah.
Right? So you are shifting these 2 bits toward right, you are losing them. But if you are during shifting, if you are losing 0, then your answer will be correct. Okay. So now let's see what is this binary. 1 2 4 8 16 32 64. So 64 plus 16, how much? 64 plus 16.
80.
80.
Yeah.
Okay. What answer we are getting here? 1 2 4 8 16. 16 plus 4, 20. Right? Is this
Yeah.
answer correct?
No. Oh, yeah, it's correct. 20. Yeah, yeah, 80 divided by 4.
Divided
Yeah.
by 2 raised to power 2. This power
Yeah.
2, this power is representing number of bits you shifted. Okay, number of shifts. So 80 divided by 4, what is the answer? Answer is 20, and you are getting binary of 20 as a result. So this answer is correct. Okay. So if they will ask you, write a comment on your answer, you will say this answer is correct because the corresponding denary value of original binary is 80, and the resultant binary belongs to denary number 20, and 80 divided by 2 raised to power 2 is also 20. That's why answer is correct. Okay.
Okay.
But in case while shifting, if you are losing bit 1, this means you will not get correct answer. Okay.
Yeah.
So this is also done. Least significant bit, look, this bit is LSB. Whatever binary number they are giving, the rightmost bit is LSB and the leftmost bit is MSB, most significant bit. Okay.
Yeah.
Now, 2's complementary. Why we use 2's complementary? 2's complement. Why we use 2's complement?
2's complement, it's basically we use it to find the negative,
Yes.
a negative number, denary of a negative
Computer represent negative numbers
in
using
binary.
2's complement. So otherwise, how computer will, if I'm asking how 24 is represented by a computer, or let me take a simple number, let's say 20. So 20 means 1, 2, 4, 8, 16. So 1 plus 16 plus 4 is 20. So in a 8-bit register, this is the binary of 20. 1, 2, 3, 4, 5, 6, 7, 8. So this is the binary of 20. But if someone is saying how computer will represent minus 20, now this is problematic. How we will store minus 20? So to solve this problem, 2's complement comes in picture. In 2's complement, the most significant bit is minus 128. Okay. Other values are as it is. The way we are assigning here. So the MSB is always minus 128 in 2's complement. In 2's complement. 1, 2, 4, 8, 16, 32, 64. Okay.
Yeah, got it.
Right. And if inside this MSB, if you are putting 1, so 1 indicate that it's a way of representing negative number. Represent negative number, negative integer. Okay. But if in this box you are putting 0, so 0 indicate that you are representing positive number in 2's complement. Okay. So MSB 1 means negative number, MSB 0 means positive number. So tell me how we will represent plus 28 in 2's complement, because this question is also common. You have to represent positive number in 2's complement. So tell me what we will write.
Okay, so you'll basically just write
Hmm?
the same thing except it'll be
Hmm.
so basically, for example, if it's uh 20 for okay, so if it's 20 positive 28, then you basically just write
This is minus 128. In this place, we will put 0. 64, 0. 32, 0. Do we take 16? Yes.
yeah.
8.
Oh, and then you add 1 to
Is this the answer?
uh
16 plus 8 is 24. Right?
16 8, yeah, it's
24.
24.
24 plus 4 is time up. Okay, so we
20.
are late. Just 1 minute. Time up for chapter 1. Okay, let's extend the time. Okay, in 15 minutes, we have to finish it. Okay, let's extend the time. In 15 minutes, we will finish it. Finish this chapter 1. Okay, let's go fast. I hope this is clear. Minus, if you are representing any positive number in 2's complement, the MSB is always 0. Right?
Yeah.
Minus 128. Otherwise, 16 plus 8 is 24. 24 plus 4 is 28. Okay? Now, how you will represent minus 128? This is minus 128. This is 64. This is
You just do
32. Let's solve it together. 16, 8,
minus 20.
4, 2, 1. Okay?
You do 1 in 121, and then you make all of the other ones that so for 28, the other ones that were 0 become 1. So for example, 64 becomes 1, 32 becomes 1, But 16 and 8 and 4 all become 0, and then yeah.
Okay, let me cross check. So you are saying minus 128 plus 64 plus 32 plus 2 plus 1. You are saying this, right?
Yeah. Yeah.
Let's quickly cross check. Because I usually count them. So 32 plus 64 plus 2 plus 1 is 99. Then minus 128 is minus 129. It's minus 29. Are we putting 1 here?
Yeah.
Again, let me check. 64 plus 32 plus 2 plus 1, 99. 99 minus 128 is minus 29. This answer is incorrect because I usually not solve like this way. I usually calculate. Answer is minus 129. So
Okay.
we have to solve this because we can't convert them. We are not flipping them. Flip method is different. I have another method. I will teach you that also. Quickly tell me what is minus 128 plus 64.
Minus 128 plus 64. Wait, minus 4, 68, 80, 60,
It is minus 64,
64.
right?
Yeah.
So it is in range. So we are putting minus 64 here. So now
Yeah.
we have minus 64. Now minus 64 plus 32. Tell me how much?
Then it'll be 32, minus
Minus
32.
32. So it is also in range. So we are taking, whenever things will go like bigger than this or lesser than this, then we will not take that number. So minus 32. Now tell me minus 32 plus 16. How much? Minus
Again,
16.
minus 16.
So we should not take it because minus 16 means
Yeah.
it is bigger. Negative number, no, it is bigger. It is smaller than minus 28. Okay. So we will
Yeah.
not take it. So minus 16, we will not take it. We are not taking this. Now tell me minus 32 plus 8. Tell me.
Minus 32 plus 8 is still, it's still gonna be more than 28. You can't take it.
You can't take it because it is like smaller than this number. So we are not taking this. Now tell me minus 28
You can
plus 4.
take, you can take 4.
Minus 28 plus 4. What will be the answer?
30, minus 32.
Minus 24.
Oh, minus
Sorry,
24.
just a minute. Then we do, this calculation was wrong then in that case. 8 minus 32 is minus 24. Okay, so we are not taking it. 4 minus 32 is minus 28. We are taking it because minus 32 plus 4 is minus 28 and then other values are 0. Okay. So Gia, you will not apply this formula that you are just finding corresponding binary of plus positive number and then you are flipping it. This formula will not work.
Okay.
Okay. Actually, you are mixing two methods. Is this clear?
Yeah.
How you will solve this? Again, I'm telling you, you will just keep adding them. Minus 128 plus 64 is minus 64 because minus 64 is a bigger number than minus 28. That's why we are considering. Then minus 64 plus 32, it is minus 32. So because it's a bigger number than minus 28, we are taking it. But minus 32 plus 16. So the answer you are getting is minus 16, which is smaller than minus 28. That's why we will not take it. Is this clear?
Yeah.
Okay. We have another method. If you want to calculate minus 28 in 2's complement, the first step is find binary of plus 28. Find binary of plus 28. So what is the binary of plus 28?
Okay, so binary of plus
0,
28
0.
is 0, 0, 0, 1, 1,
Hmm.
1, 0, 0.
Okay, let me see. 1, 2, 4, 8, 16. 16 plus 8 is 24. 24 plus 4 is 28. So your answer is correct. Now the second step. Second step is this, flip them. Flip means invert them. 0 become 1, 1 become 0. So tell me the answer. 1,
So,
1, 1, 0, 0, 0, 1, 1, right?
yeah.
So First step, find the binary of corresponding positive numbers. Second, flip them. Third step, add 1. Third step, add 1. So if you are adding 1 into this, what answer you are getting? 1, 1, 1. Okay, not like this. We will solve it from here. 1 plus 1, 0. With
0, and then you carry 1.
0 with carry 1. Other numbers are same.
Yeah, so then
0, 0, 1, 1, 1. This is the answer of minus 128.
oh
We are getting same answer, right?
yeah.
So find binary of positive, flip them. Flip means 0 become 1, 1 become 0, and third step, add 1. Okay?
Okay.
Okay. Now, this is also done. Quickly tell me what is ASCII and what is Unicode.
Okay, so ASCII, they're both numbers, they're both sorry, character sets basically.
They are both character set, or we can say instruction set.
Yeah.
Every CPU, every computer comes with pre-built, inbuilt instruction set. Okay, so these are the instruction set. Because
So
whatever key you will press from your keyboard, every key assigned a unique number, and this number then converted into 0 and 1. So this is the character set. Okay.
yeah.
Tell me how many bits are used to represent ASCII character.
Originally 7, but now there's 8.
7-bit and 8-bit ASCII. 8-bit is a extended ASCII set.
And,
Extended ASCII. And this is 7-bit. 7-bit means 2 raised to power 7. How much 2 raised to power 7?
128. So 127.
128 characters. And this is 256 characters. So this means ASCII can represent only maximum to maximum 256 characters. Okay.
Yeah.
What is Unicode?
Unicode is basically it's more modern, and it basically can hold way more bits, and it's now what we use universally in our computers.
If I'm asking you,
Like special
three
characters,
tell me 3 features of Unicode, what you will write?
okay. So it can hold special characters like emojis. It can all of that. It can work in many different languages, not just English and Western languages.
It is single feature. Like you have to combine these 2 features and it's gonna be one only.
Okay, and then another
You
one,
can see it is mentioned here. Unicode allow for a greater range of characters and symbols than
yeah,
ASCII, including different languages and emoji. It's a one feature. It's a one feature.
and it holds, okay, so each bit in Unicode holds more characters.
It's the same
Oh,
language.
sorry. And each character in Unicode is represented by more bits.
Right. Unicode require more bits per character than ASCII because you know what? In Unicode take 4 bytes to represent one character.
Mm-hmm.
Okay, Unicode take 4 bytes to represent one character. So it is occupying more memory. So we can write it occupies more memory. But if you are just writing more memory, you will not get full marks. You have to write in a complete sentence. Unicode takes more memory because 4 bytes are used to represent one character. Third feature is it is supported by.
It is compatible and supported by a lot of different, all of the different, like
Platforms, operating
that
system, web
operating.
browsers. Okay, it is supported by all platforms, operating systems, and web browsers. Okay, and the
Yeah.
first feature is this one, and Unicode is very important topic. ASCII basically represent English and English-based languages and only limited characters. Okay,
Yeah.
ASCII 1 byte is used to, so if they are asking you 2 characteristics, you can write it takes less memory to represent one character. Fine. Now let's
All
compare. Computers understand how and why a computer represents sound, including the effect of the sample rate and sample resolution.
Okay.
Okay, tell me, let me ask few questions. Amplitude, what is amplitude?
So amplitude is like basically the loudness of the sound. So it's like
And what
the
is sound? Okay, you are right. What is
it's a
sound?
sound wave, and then the
Mhm.
amplitude is like the top of it. The distance between the top.
Air, or we can say vibrations, vibration in air, right? Okay.
Yeah.
There are two important terms for your exam: sample rate and sample resolution. How you will define them?
So sample rate is basically how many samples are there per second, or the frequency of samples
Number of samples taken per second.
per second. Sorry,
Okay.
yeah.
Sample
And
resolution.
resolution is basically the bit depth.
Number of bits used to
Yeah, number of bits used to make up the sound, the
represent
one
one sample. Number
one
of
bit.
bits required for one sample. Okay.
Okay.
You can see sample resolution is the number of bits per sample. Fine. Okay.
Yeah.
Let's say this graph is representing sound. Okay. I have one question I'm showing you. Just give me 1 minute. Okay. I'm showing you one question and you will tell me answer from here. Okay. It's a different paper, different board, but like topic is same. Let's say I'm just updating this. This is the graph. An analog to digital converter is used to hello, am I audible?
Yeah.
Okay. Change the sound received by a microphone into a form that can be processed by a computer. Complete the diagram to show a sample interval and label boxes, label axis. So I'm telling you, in this type of graph, the horizontal axis is always time, right? In seconds, basically in seconds.
Yeah.
Fine. And this thing is amplitude. The y-axis is amplitude. Okay.
Yeah. Yeah.
And change, and let's say this is 1 second, then this is 2, let's say this is 3, right? And
Yeah.
here I am drawing some lines. So in 1 second, how many, this part is known as sample, like this part is known as sample, right? Now how many samples we are taking in 1 second? So let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you are taking 11 samples in 1 second. Can you tell me, in this graph, as per this graph, what is the sample rate?
Okay, so as per this graph, the sample rate is,
What is the definition of sample rate?
yeah, it's the number of, it's basically the frequency, it's the number of samples, it's the number of
Right.
samples per second.
Per
So
second. So 11.
on 1 second, sample 1, 2, 3, 4, 5,
Maybe
11.
it's very messy, but otherwise you can see, let's say this is 1. And how many samples you are taking? 11. So you are drawing these lines. So these are 11 samples. So this means the sample rate of this sound is 11 hertz.
Yeah.
Okay? But if in this question you are just writing 11, maybe you will not get full marks. You have to show measurement units, hertz.
Yeah.
Okay, first thing. Now second thing. Now I'm changing. Is this clear?
Yeah.
Okay. I'm changing this graph little bit. Or let me draw this graph here. Let's say this type of graph is there. Fine. This is 0,
Yeah.
then 1, then 2, then 3. And ऐसा करते करते, let's say this is 18. This is 18. Okay.
Yeah.
This is, let's say, 6. This is, let's say, 10. अब मुझे बताओ कि in this graph, what is sample resolution? What is sample resolution here?
Okay, so sample resolution here would be
Quickly tell me the definition of sample
18.
resolution.
18. It's the number of bits
Number of
used.
bits means answer will come in number of bits. Number of
Right.
bits used to represent sound. Okay. So number of bits used to represent amplitude, I think. Amplitude.
Yeah, so
Loudness.
18 because it's
18.
a
But
higher.
18, it's a number. How many bits are used to represent 18?
So
1,
wait,
2.
1, 2, 3, 4, and then one more, so 5 bits.
So 16 plus 2.
2, so 5.
So maximum 5 bits. So we will say in this graph, 5 bits. 5 bits are it's a sample resolution. Is this clear? Okay.
Yeah.
I hope we are covering everything here.
Yeah.
Okay. Now, sample. Okay. This is also very important question. The effect. If you are increasing sample resolution, what will be the effect? If you are sampling result is high, then what will be the impact? So this is the book. I hope I am sharing my entire book.
Yeah.
Right. This is important. Okay. So
Yeah.
benefits and drawbacks of using a larger sampling resolution. So they can ask you what are the effects of larger sampling resolution. So larger dynamic range, better sound quality, less interference, less sound distortion. And what are the drawbacks? Obviously, if the quality wise it is high, then obviously it will take more size in memory, right? And if file size is big, then obviously it will take more time to download and transmit. Okay, it require greater processing power as well. Fine.
Okay.
Okay, now let's come to okay. Okay, another question which is important here, the working. Okay, like how microprocessor read the sound. So this question is also important, so you will make your answer from here. Sound waves are vibration in the ear. Each sound wave has a frequency, wavelength, and amplitude. Then you will write sound waves vary continuously. That's why they are analog in format. So whenever we are doing sampling, the sampling will be happened in an analog form, means we need ADC to convert them into digital so that microprocessor can understand this. So convert the analog data, the sound waves are sampled at regular time interval. Okay. The amplitude cannot, okay, only this part, time interval, that's it. After that, you will not write this example. That's it. This much. Okay.
Yeah.
Okay. Now let's come to the image. How computer is representing image. So quickly tell me, what do you understand by pixel?
Pixel would be like one one color, like
A smallest unit of,
smallest unit that makes up an image, basically.
right, a smallest unit of any digital image, right?
Yeah.
Any digital image, and it's known as picture element. Pixel means picture element. Fine. So if your image is black and white, this means you need only 2 pixels. One is for black and one is for white. So this means you can see 1 bit per pixel, and if 2 raised to power 1, because you are needed 1 bit for each color. Okay. So
Yeah.
one. If each pixel is represented by 2 bits, so this means 2 raised to power 2 combination are possible, 4 colors. So it is representing 4 colors. But if you are writing 2 raised to power 8, so 2 raised to power 8 means 16. No. How much? 256. So if you have 8 pixels, 8 colors for each image, then we can say 256 colors are possible. Okay. Now,
Yeah.
what is important here in this topic? Pixel definition is important. Color depth definition is also important. What is color depth? Quickly tell me.
Okay, color depth is like how many
Bits are
basic
used.
bits are used to represent each color. So
Right. Nowadays, modern computers are using 24-bit color depth. Why so? Because every color is made up of RGB, red, green, and blue. Red is taking 8-bit space in memory. G is taking 8-bit. B is also taking 8-bit. So 8 in plus 8 into plus 8 is 24. And how many shades of red color are available? 2 raised to power 8, which is 256. So 256 into 256 into 256, approx 16 million color are supported by high definition digital image. Okay.
okay.
Is this clear?
Yeah. Yeah.
Fine. So this is done. High resolution, what is the impact of high resolution? It will take more memory. If it is taking more memory, this means file size is big. This means it will take more time to transmit and download. Okay. Download and upload time is higher. And what is this? These are the main drawbacks of high resolution image. Otherwise, if your image is high resolution, this means the quality is very like with great quality, no pixelate, very clear image. And these are the drawbacks.
Okay.
These are the drawbacks, that it will take more size and more space in memory and all. Now let's come to next topic, compression. Compression is very, 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 very important topic every year. Whatever paper I have checked today, in all the papers, they were asking compression. Can you tell me what is data compression?
Yeah, so compression is basically there's two types, lossy and lossless compression.
But what is,
And
no, I'm not asking types. I'm asking what is data compression?
okay. So compression is basically it's basically methods of reducing file sizes
Right.
or
So
like
that
how much storage is needed, how much storage space is needed.
you are right, right. You will just write only one line. It is a way of compressing or reducing file size. Quickly tell me what is lossy file compression.
Lossy file compression is basically um,
A way,
it's you can't get the original you can't get the original file back because
right.
it leads to like loss, and so
Right.
it's good when you're applying like for images or whatever, but
No,
if
we
you
will not write whatever. We will say sound. Uh,
yeah.
uh, video and image files. The loss of video and image files are bearable. Why? Because whenever we are losing some pixels, whenever we are losing some sound, then this loss is not very much identifiable. Okay, because human ear and human eyes have some limit. So if we are removing some same kind of shades from any image, some pixels, it is not actually very noticeable. So it is better to apply lossy compression on images and videos. For example, mp4, jpeg, these are lossy file compression techniques. Okay.
Mm.
You have to Jia, you have to learn this topic, this thing. This is also very important. Okay, I will come to lossy and lossless again. First, let's quickly
Yeah.
discuss this. How you will define bit? Define. I'm asking define.
Okay, so a one bit, so a bit is the smallest like
Unit of
uh
memory.
unit of yeah.
It's the smallest unit of measuring measurement in computer, right?
Mm.
Let
Yeah.
you can see bit is the smallest unit of all computer memory storage. Quickly tell me, one nibble is equal to how many bits? One
One
nibble.
nibble is 4 bits and one
4 bits. Okay.
byte is 8 bits or two nibbles.
Right. And then 1 KB byte is equal to 1024 bytes, right?
And then it keeps multiplying by 1024.
Right. But you have to learn this table. This is very important. 1 KB byte means 2 raised to power 10 bytes. 1 maybe byte means this. You have to learn this table. This table can come directly 1 PB byte dash byte. So you have to learn this table. It is important. Okay.
Yeah,
Okay.
yeah.
Now calculation. Where is lossy? Where we missed it? Okay. Lossy we have discussed. Whenever they will ask you write any 2-3 features of lossy, so the first feature is it's a technique of reducing file size. First point. Second point, it eliminates unnecessary data from the file. This is the second point. Third point, the original file cannot be reconstructed once it has been compressed. This is the third feature. Okay, if this question is of 3 marks, you will write these 3 different points. If this question is of 4 marks, you will write some example also like JPEG and MP3 and MP4. Okay.
Sure. Okay.
Okay. So this is clear. Lossless. Quickly tell me lossless.
Lossless is basically compression without like loss of any you can get, or it's for like files where you need to like get all the data reconstructed. Like
Okay.
for example, if it's like a really important like text like file or
Mhm.
something like that, and so basically it won't damage any of the original data stored.
Right, because we can't afford any loss in our text file. It will change the meaning. It will corrupt our file. File can be corrupted because if you are removing some data, means file is corrupted. Okay.
Yeah.
Image means lossy. Image song means lossy. You can apply lossy. Text and source code. Project file. You will go with lossless. Okay.
Okay.
So all the data can be, so this lossless file compression is a technique to reduce the file size. The data from the original file can be reconstructed. It is important for files where any loss of data would be disastrous. For example, a spreadsheet, word processor, or any data. Okay.
Yeah.
Run length encoding. These 4 points are important. Please run it. You have to learn them. RLE is a way to apply lossless compression, but it is successful for only those files where files are containing repeated pattern of string. Okay.
Yeah. Okay.
Otherwise, if in your file you don't have any repeated character, then run length encoding is not very advisable. It is a form of lossless. It reduces the size of a string to a string of adjacent. A repeating string is encoded by two values. The first value represent the number of identical data. So this is small a. So how many A's we have? 5. So we are writing 5. The second value represent the code of the data. So capital A ASCII value is 65. Small a ASCII value is 97. So that's why we are writing 97. You can see this is misprinted here. A is here. 597. So B means how many B's? 4. 98 is the number we are assigning to B. C, we have only 2C, 99. We have 5D, 100. Now you can see what is the file size of original file. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 byte is the original size, but now you can see how many numbers we have. 2, 3, 4, 5, 6, 7, 8. 8 byte. Okay, so compression is happening.
Yeah.
Right? I'm showing one question. Describe one effect of using lossy compression to reduce the size of file. What answer you will give here?
Okay, sure. Lossy compression to reduce the file. So you can use lossy compression, like if there's a photography file. Oh, okay. If one effect, it'll lose some of the it'll lose some of the resolution. Like for example, if it's an image, it'll lose some resolution, so it'll be less clear.
Right. So one effect is you can the one effect is losing some data, some unnecessary data, which can have a impact on quality. So quality may be degraded, but it is not very noticeable. Quality degraded, but not noticeable. Okay. Now next is okay, not this. I want to ask. Okay, you can see. I just want to ask question on RLE. That's why I'm showing this. A run length encoding algorithm reduces the size of a file based on the runs of repeated item. For example, this would be reduced to 3W2B. You can see how many W we have? 3. 3B. Okay, and so on. Why RLE may not be good choice for encoding a text file? In this case, it is good. But why sometime it is not good? Tell me. If text file is not containing repeated pattern of characters, frequently, then run RLE is not suitable. Because if things are not repeated, then how it will assign, it will count. It is basically counted repeated characters and then giving some unique number to it. Okay. So
Yeah.
if your text file is not containing repeated letters, then it is not good. Fine.
Yeah.
Okay. Each and
Right.
everything is important from lossy and lossless. So you have to read all the examples of this book, and everything. Actually, compression is very, very, very important. You can see this is also important. How mp3 file, how we can compress any sound file without any notice of degradation and all. So how it is working? So this compression technology will reduce the size of normal music file by 90%. They can make question directly from this point also, how it is reducing 90% file size. Then we will say this is the point. It removes sound that the human ear can't hear properly. This is the first point, which is outside the human range. First, this is the first point.
Yeah.
Second point is, if two sounds are played at the same time, only the louder one can be heard by the ear. So the softer sound can be eliminated. This is called perceptual music shaping. So whenever they will make question from this thing, how it is compressing 90%, then you will write this technical term, perceptual music shaping, which is important. Okay.
Yeah, it's in.
Right. And this thing JPEG, they can like twist your this question. Then you have to keep these 2 points in your mind. Human eyes don't detect differences in color shade quite as well as they detect difference in image brightness. Okay, so if you are removing some pixels of same shades, it is not noticeable. So by separating pixel color from brightness, images can be split into this block, for example, so which is not very noticeable. Okay. So you have to write all these points. This is very, very important. You should write like proper answers for lossy and lossless. Color depth we discuss. Color depth is the number of bits. This definition is important. Number of bits used to represent each color. Okay. Now let's quickly come to the formula. These formulas are important. Let's quickly revise them. Image resolution into color depth. This is what is image resolution? Total number of bits or pixels used to represent image, height and width, file size.
Yeah.
How you can calculate file size of sound? Sample rate in hertz, sample resolution in bits, and length of sample in second. This is the formula. You have to learn them. And okay, this is the question. Not this. Quickly tell me how we can solve this. An image uses a 12-bit color depth, 64 pixel wide, 48 pixel high. Construct an expression to calculate the file size of the image in maybe byte. What should I write?
Okay, so basically you have to write that
64 by
64 times 12, 48.
48. So this is actually image resolution, right? By
Mm-hmm.
12. It's a color depth.
Yeah, so you have to, so then it's that.
But this answer will comes in bits. How we can convert in maybe byte?
Okay, so then you have to, because it's megabyte, so you have to divide it by
Eight.
one
Divided by 8. So once you are dividing by 8, answer in bytes. Now, how many bytes are used to represent 1 KB byte? 1024. So when
1024 and
dividing
then
by
one more 1024.
right. So one, now in this case, it is KB byte. Now, if you want to convert KB byte into maybe byte, again divided by 1024. Then you can simplify it. Okay. So you will try to simplify it. Fine.
Mm-hmm.
Okay. So this is also done. So you will solve all the examples of book of calculating this. Okay. And you can see the amount of the previous. So this thing via calculation is done. Okay. What is the purpose of data compression? Why we are compressing the data?
Okay, so you have to compress it. Okay, first of all, it makes faster transmission,
Mm-hmm.
less storage space needed, and less power required, less like energy required to transmit, to trans.
Less energy, less power we will not use. We will just use. First, you are saying it takes less memory space. Okay, so this is approved. Why you are compressing the file? Because it will reduce the file size. It means it will take less memory. This means we are saving our memory. And if the file size is small, means it will take shorter transmission time. The download time, the upload time is less. The third benefit is it takes less network bandwidth. Okay, less
Yeah.
network bandwidth. So in low network bandwidth, we can send our big file. Sometimes they will ask you that there is an email and I want to send you email, and in this my file is like why it is important to compress the file if I want to send this file through email. So what you will write? Compression is needed so that it should come in the range of email storage. Like there is a limit in email application where you can send data with limited storage. So it will come within that limited storage. That's why we are compressing it. Okay.
Yeah.
Okay. So this is also done. Now this is okay. Quickly read this. Lossless compression reduces the file size without permanent loss of data. And example, run length encoding. There is another example, .zip, .png. These are the example of lossless. Lossy compression reduces the file size by permanently removing some data and it cannot be reconstructed. It reduces the resolution of image. It reduces the sample rate or resolution. So this is the impact or effect of lossless. Lossy, sorry. Okay, so this is done. Now let's come to chapter 2. Chapter 2 is equally very important. Understand the data is broken down into packets to be transmitted. Quickly define what do you understand by packet.
Okay, so a packet is like basically there's a packet is like how data is basically broken up into many different packets, and one packet contains three parts.
No, no, no.
Um,
I'm just asking what is packet. What is data packet? So you will
okay,
say
so
data
one
packet is
packet
a small unit of data traveling over the network. Okay.
okay.
This is the definition. This question can come of 1 mark or 2 marks. So you will not describe structure. You will not describe any packet switching. If they are asking define data packet, you will just write it is a small unit of data traveling over the network.
Okay.
That's it. Nothing else. Okay. Now tell me, now 3 marker question. Quickly tell me the structure of packet.
Um, okay, so there's three parts. There's a
Okay,
header
header.
which contains the address of the sender,
Which kind of
the
address? IP address or MAC address?
IP address of the sender, IP address of the receiver, and then the packet number, like what the number is, like in the order.
Packet number, okay, sequence number, and the
And then
size of packet also.
okay,
Okay, and then the second part,
then there's the payload, which is the actual data,
yes, it contains actual data. Third part,
and then it's the trailer, which is the error checking
it
part.
contains error checking methods, right?
Yeah,
Error
yeah,
checking methods means checksum, ARQ, and all. Fine. Okay.
yeah.
Describe the process of packet switching. So if they will ask you packet switching, it will come of 5 marks. I'm writing some keywords. You will make your answer using these keywords. Packet, sender device, router, sender router. You can use sender router also. Then
Mm-hmm.
different paths, then reassemble, assemble, destination router. Now quickly tell me what will be the answer. Describe process of packet switching.
Okay, so basically, packet switching is how, like basically, something being transmitted is divided up into different packets and then sent in different routes, from one router to another router. And so basically, once they all reach the receiving router, then at that point they'll be reorganized into the order.
They are out of order. Okay, they are reaching to the destination router in out of order. So destination router will reassemble them as per their packet number. Then this data will go to the receiver device, right?
Yeah.
So whenever one device wants to send any data to another device over the network, data is broken down into packet. Each, then if this question is of 6 marks or 8 marks, then maybe you will describe packet also. Each packet contains header, trailer, payload and all. Okay. Each
Uh-huh.
packet will take different routes, and uh, the router within the path will control the route. Okay, a packet takes. Packet may arrive out of order at the destination device. The destination router will arrange them as per their sequence number, and then they will be readable to the destination device. This whole process is known as packet switching, and it is very important. This entire part is very important.
Uh-huh. Okay.
Okay. Now next. Data is transmitted from one device to another using different methods. So methods are divided into parts. Serial and parallel means number of bits. This is the factor which is based on number of factor. The factor is how many bits you are sending from one device to another device. Simplex, half duplex, and full duplex means the direction. What is the direction? Can sender send the data to receiver, or are they able to send data in both direction at a time or at the same time, simultaneously or one at a time? So these are the factors. Quickly define serial data transmission. How you will define serial data transmission?
Okay, so serial data transmission.
Hmm.
Serial means basically there's only um one
One
serial
bit
means
at
there's
a time,
one at a time, and only one direction.
sending one bit at a time over a single wire.
Over a single wire. And then parallel is there's
Okay,
two.
instead of wire, you can use channel as well.
Okay. And
Parallel,
then parallel is several different bits, and
sending
there's
multiple bits at a time over the
over multiple wires.
over multiple wires, right?
Yeah.
Simplex, this is your sender and this is your receiver. Then what is the mean of simplex?
So then the meaning of simplex will be only one direction.
Data will go in one direction only. What is half duplex?
Half duplex is both directions but can't be at the same time.
Right. Full duplex?
Both directions at the same time.
What is USB?
USB is like the thing that they send it. It's the wire. It's the
Oh, no,
universal.
no, 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 no. It's a universal serial bus. It's a universal serial bus. Nowadays, in all the devices, you have that port, right? You can connect any mouse, you can connect any keyboard with a USB port, right? If
Mhm.
you are connecting keyboard with your computer through USB port, then what kind of communication is happening here? I'm giving you, out of all these options, USB is based on what?
USB is based on it has
Serial and half duplex and full duplex. You have to learn this because this is very important. Are you understanding what is USB port? Your mobile charger is also USB. Type
keyboard, yeah.
C. Do you know Type C charger? Right?
Yeah.
So it is
Yeah.
also a USB. But if you will check pen drive, the port we using it's a USB port. So if you are connecting any kind of device with your computer, obviously some transmission is happening. Okay, you are sending some data, but how this data will go? The data will go, it is based on serial. Serial means 1 bit at a time. That's why there are no chance of data being skewed. Why? Because only 1 bit is traveling at a time. Okay. And it is half duplex and full duplex, because obviously you can take data from the pen drive and you can put it as well, right? So communication can happen in both direction. Sometimes at the same time, sometimes one at a time. It is your choice. Is this clear?
Yeah.
Okay. Quickly tell me suitability, okay, advantage. Quickly tell me 2 advantages of serial data transmission.
Okay, so two advantages are it can go long distance.
Serial
Is that
serial are best suited. So serial transmission is best suited for long transmission, long range transmission. Why?
because it won't it's like it won't like get
Because only 1 bit is traveling at a time, so data will not be skewed. Okay, data will not skew.
skew.
Okay.
And then that's another, isn't that another point also, that it's best because there won't be any like um bits skewed, and then also
We
that
can write less expensive.
it's less expensive because, yeah, obviously
Because only
parallel.
one wire, okay, one channel. So you are not buying multiple channels. You have only one wire. That's why it is less expensive. Best suited for long range transmission because only 1 bit is traveling at a time. So it will take, like data will not skew. Okay. Now,
Yeah.
please tell me, okay, disadvantage of serial.
Um, Disadvantages of serial are
Slower.
that it's slower and it
Can you tell me why it is slower data transmission?
was only one bit at a time, so
Only 1 bit
obviously.
at a time. Okay, so this is a disadvantage. Quickly tell me advantages of parallel. Okay, let's quickly read it from here so that we can finish it. Mm. So they can ask you 2 advantages. It works well over long distances. The disadvantage, slower rate than parallel, and the reason is same, 1 bit at a time we are sending. Because only one channel is used, data will arrive at the destination fully synchronized, means data will not skew. Okay. And the
Yeah.
example is computer to printer via USB connection. So you can give any example of USB port, okay, pen drive or anything. Parallel
Oh,
data transmission advantage, it works well over short distances and it is faster. Short distances, because if you are sending data to long distances, data can become skewed or unsynchronized. The longer the wire, the worse this become. However, it is a faster method of data transmission than serial. The internal circuit of computer. So, Jia, if they are giving you any scenario that inside a motherboard, CPU wants to send some data to RAM or any other component, if you think this is happening within computer inside the motherboard, then you will take this example parallel. But if something is going outside the computer, let's say printer, then you will choose only serial because it is actually long distance. Okay.
yeah.
Okay. This activity 2.2 is important. So for your revision, you should solve all the activities. So explain the mean of this. Now you can see data is sent 1 bit at a time. Serial, one direction only means simplex. So what we will write? Serial simplex. Okay. Now quickly
Yeah.
tell me, data is being sent 16 bit at a time in both directions simultaneously.
That means it's a parallel full duplex.
Parallel full duplex. Okay, so you know how to write this. So this is also done, serial simplex, and these are the comparison chart. So we already discussed this, right? Serial is less expensive. It is expensive because multiple wires has been used.
Okay.
Serial is always more reliable, always more reliable. It works well over short distance. It is faster. It is slower always. It is faster always. Now let's quickly come to USB. USB, you just need to know one important thing. It is serial, half duplex and full duplex data transmission method. Okay, you don't need to learn this wire and all. Now, how computer will detect new device, these points are important. Computer automatically detect by loading the device drivers, and if new devices detect, the computer will look the device driver or will prompt to download the appropriate driver from the internet. Okay, so this is important. Now, benefits and drawback, you have to learn any two benefits and two drawback of USB. No need of external power source. Another thing is it is industry standard. What it means industry standard, let's say you have a laptop of HP and you are buying let's say you have a laptop of Mac, you are buying let's say keyboard of HP. So these are two different vendors. Mac is a product of Apple Incorporation. HP is itself a company, a different vendor. If you are buying any product of HP, you can easily connect it with a Mac. This is known as industry standard because they are providing common ground on which different devices, different software from different vendors can communicate. So that's why USB is a industry standard. Okay. It
Yeah.
support different transmission rate because you know this thing. Type C is very faster than normal USB, right?
Yeah.
So it can support different transmission rate. It is relatively easy to add more USB port if necessary by using USB hub. USB is backward compatible also. Like in your laptop, you can use like old pen drives. Okay.
Yeah.
It is automatically detected. So these are the advantage. What is the drawback? We have only two drawback. Maximum cable length is 5 meter only. Another thing is that still there are lots of laptops which are not supporting backward. For example, the Mac, that my Mac is M3 Pro. It will not support these backward compatible USB. It is supporting only Type C. Okay.
Oh, yeah. Yeah.
Okay. So this activity is important. You should solve this. This activity, page number 53. Please note down. This is important. Okay. So you will solve it later. I will share you answer key. Now, let's come to method of error detection. This chapter is, I'm telling you, Gia, very important. You should learn checksum. You should learn ARQ in detail. Echo check, parity check. Fine. So
Yeah.
let's quickly solve this parity check. Parity check, we are solving only one example from here. Okay. What is this parity check method?
Parity check method is basically they add like a parity bit at the end for even or odd basically. So even if there's like a even number of one bits, or odd if there's an odd number of one bits in the thing.
Okay. These are error detection method only in the case when your data is transmitting over network. When data is transmitting over network, then in that case these are the method. But if we are writing check digit is also a error detection method. It is a error detection method. It's a error detection method, but only data entry check, only in case of data entry. For example, if you are reading something from a barcode scanner, then the data is copied correctly or not into the system. That's it. So whenever in your exam they are asking describe two error detection method over the network or something like this, these are the four methods, because this is not, the check digit will not work on network. It is not related to network. Okay, it is just a data entry thing. Okay.
Yeah.
Now, in first one is parity check. Sender and receiver will agree on uh, common parity. Like I am sending you some data, let's agree on even parity. So if they are agreeing, they have an agreement on even parity, so data will contain even number of ones, right? You know this thing, right?
Yeah.
And this receiver will count, okay, I am receiving this data. Are these bits have number of ones even? Then they are agree. So now you can understand this is not very reliable. This is not a reliable method. Okay. I'm showing you one question which is important to learn. Like why it is not reliable. It is here. You have to learn it. Like why error occur? Question is that why error occurs during the data transmission? This is important from my side. It came in IGCSE 2 times, I think. Error can occur during data transmission. Whenever data transmission word is, we are using data transmission word means sender is sending some data to the receiver over the network. This is the data transmission.
The transmission, yeah.
So why error is coming? Because of interference. Maybe cables are suffering with some
Or
electrical
there could
interference.
be malware or something.
Can be, because if data is traveling wirelessly, then also malware can come. Hackers can intercept the data. Okay. Problems can occur during packet switching. You know this point. When packets are traveling from one router to another router, and if one router is very busy, they will keep hopping. Like they are going here and there. If there is too much traffic over the network, then packet will hop here and there, and we will lose it after some time. Okay. So if you are losing any data packet, this means problem is occurring. Skewing of data, you are sending multiple bits and they are skewed, out of synchronized. Like one bit, if you are sending 0 1 0 1, let's say, over multiple wires, let's say instead of this 0, this 1 is reaching first. This means answer will be skewed. Okay, fine.
Yeah.
So these are the reason. Data can be skewed. Packets, we can lose packets during the data transmission. Some interference can happen, maybe because of hackers. Maybe your cable is cable is not proper, it is broken. So then also due to some interference. Okay. So you have to learn this. Parity, let's quickly solve this question. This one. First, let's see this. Which of the following received byte indicate an error has occurred following data transmission? We are sending this data. An agreement is happening on even parity. Tell me, is this correct or not?
Even parity, so 1 1 1. Yeah, no, it's not.
It's not correct. How many ones you have in this data?
6.
6 means even. This means it is correct.
Oh, yeah.
Right? So 1, 2, 3, 4, 5, 6. 6 number of ones means correct. Now let's next one. 1, 2, 3, 4, 5. So this means this data is erroneous. This data is error, containing error. This is not actual data. Why? Because agreement happened on even parity, but this data is not containing even number of ones. Right?
Yeah.
Okay. But it is not reliable method. You know what? Why it is not? Let's say 1 0 0 1 1 1. Let's say this is the original data. Okay. The only form of sending data or checking data is that agreement on even and or parity. Let's say there is an agreement on even parity, means this data should contain number of ones even. But during the transmission, let's say there is an interchange of these two bits. So 1 0 1 0 1 1 0 0, and receiver is receiving this data. Tell me how many number of ones we have at the receiver end.
1
2 3 4.
4. So
It's even.
So even, yeah.
This
But
means it is not reliable, right?
it's not
So
because it's
now this is the question. Why parity check is not reliable method?
Because if two of them are if more than one bit, if it is corrupted, then it could still come as correct.
It still can have even number of ones or maybe odd number of ones, right? So
Yeah.
that's why it is very typical to identify which two bit are corrupted. Okay, so that's why it is not reliable method. So what is the remedy? So the remedy is parity block. In this case, parity block, that we will not send 8 bits at a time. We are not sending 8 bit. Instead of this, we will send entire block. Okay,
Yeah.
so one of the way, so you just tell me this is the problem. It is impossible to know exactly which bit is in the error. So the remedy is parity block. A block of data is sent and the number of 1 bits are totaled horizontally and vertically. Okay. And then the intersection point is error. Now you can see, let's discuss it with the example. The following block of data was received after transmission from a remote computer. Odd parity was being used by both sender and receiver. Quickly tell me, locate where the error. Quickly tell me, where's the error? Or just tell me how you are doing this, how you are finding the error. What you will count?
So basically you'll count the bits in each column and
Number of
each
ones. No, 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 no. Don't say bit because 0 is
one. So 1, 2, 3, 4 is here. So this is even. This is fine.
which one? Are you counting this row?
First row. Yeah. Wait. 1, 2, 3, 4, 5. So this is odd. So it's an odd number.
No, it is only 3 ones. You have
Oh,
only,
sorry. I was counting the column. Sorry.
Acha, you are counting column. So 1, 2, 3, 4, 5. This is absolutely correct.
Yeah.
Let's go solve this. 1, 2, 3, 4, 5. This is correct.
Correct. 1, 2, 3, 4, 5, 6. This is 7. This is correct. 1, 2, 3, 4, 5. Correct. 1, 2, 3, 4, 5. Correct. 1, 2, 3, 4. Incorrect. So it's somewhere here.
Yes. So this is problematic bit. 1, 2, 3, 4. Now horizontally we have to check where's the corruption. So
So it's 1, 2, 3,
this is
1,
correct.
2, 3, 4, 5, 6, 7. This is okay. 1, 2, 3. That's fine. 1, 2, 3, 4. That's incorrect.
This means the intersection point of byte 4
And
is bit
6.
6. So this is incorrect. So if we can keep 1 here, so 1, 2, 3, 4, 5, vertically it will correct. 1, 2, 3, 4, 5, horizontally it will correct. So the intersection point of column and row is the corrupted bit. Okay. So you will write bit 6 and byte 4 is the answer. Now check some. This is your sender device. This is your sender device. These are very, very, very important. You have to learn them. Okay. Sender and this is receiver. What this sender will do, this is the data that I want to send. We will apply some algorithm on this data. And through this algorithm, we are finding some value we are calculating. It can be any number, any number. Okay. So when a block of data is about to transmit, a checksum is calculated. The calculation is done on the agreed algorithm. Once we will send this data, data will become with the checksum value. Okay. Then this receiver device will again apply the same algorithm and calculate the checksum, recalculate the checksum. And in this recalculation, if the checksum value is same as the sender calculation, we will say, okay, there is no error. Okay. Please learn
Yeah.
this. If this question will come, it will come of 4 to 5 mark and it is very, very important. Checksum and ARQ are very important from my side. Echo check is very less reliable. You can just read it Okay, which is very easy. Sender is sending data, receiver is sending data to take the acknowledgement. So just read it. It is very easy to read. Okay, ARQ is very important from my side. ARQ, whenever you are describing ARQ, you have to use timeout word, acknowledgement word, positive acknowledgement and negative acknowledgement, and you will make your answer. Okay, Jia?
Yeah.
Okay, so please learn it. We discussed it so many times. ARQ checksum, proper answer, proper points in detailed manner. Check digit. If they will ask you calculate the check digit, they will give you algorithm also. So don't worry. These examples are enough to learn. Okay?
Yes, that's fine.
Right. Or check digit. How check digit is different from checksum? So checksum is actually error detection method of data transmission. It is error detection method during data transmission. Data transmission means something we are sending over the network, whereas check digit is a error detection method during the data entry. You can see check digit are used to identify error in data entry caused by mistyping of barcode. Okay, they have same kind of name but different, like it's a big difference. Checksum can be any number, maybe 39 is the checksum value, maybe 203 is the checksum value, but check digit is always between 0 to 9. Okay.
Yeah.
Okay, if they will ask you to calculate the check digit, they will give you these type of steps. Okay, how you will calculate check digit. Fine, so you can
Yeah.
do it and fine. Okay, now encryption. Quickly define encryption to me. Every year they are asking you diagrams, so you have to learn this diagram for this year. Diagrams are important. From every chapter you will check what all diagrams can come. Packet switching already comes, so it will not come. How web browser locate any web server or website, it came 2 times, so obviously it should not come. Firewall working diagram already comes, so it should not come. So for this year I'm observing ki okay, proxy server diagram can come. Okay, last
Yeah.
year I think they already ask you diagram on farming, so this year I'm predicting that maybe phishing diagram can come. Data interception diagram already come. Data interception they already asked. This is already done. Already asked. Data interception already done. DDoS already done. So what we are predicting? Trojan horse. They can ask you how, draw a diagram and show the working how Trojan like horse works, something like this. Spyware. They can ask to make a diagram on spyware. Okay. MDR and the fetching diagram already come. This means they can ask you the working of ALU, how arithmetic logic unit work. Okay, like the execution part of von Neumann architecture. So this can come diagram. Fine. And encryption, you can see they can ask this diagram. It didn't come before. So this can come this year. Plain text will be, we are applying encryption algorithm on plain text. It will convert into ciphertext. Ciphertext is something which is meaningless. Hackers can read this data, but obviously it is meaningless to them. Okay, they can't do anything. Then receiver will apply decryption algorithm, and then again it will convert it into plain text. Okay.
Yeah.
Encryption is always important, always. You will not write this example in your exam if they are asking in symmetric encryption. In symmetric encryption, only single key has been used for both encryption and decryption process. Okay. So by this way, you will make your answer. For now, just read symmetric and asymmetric encryption. Let me quickly explain asymmetric. In the asymmetric encryption, receiver will generate public key and private key. Receiver, I'm not saying sender. Receiver device is generating public and private key. Public key is on the cloud. Sender will take this public key and use this public key to encrypt the data. Then this data will go to the receiver. Receiver will use the private key to decrypt the data. Okay?
Okay.
So which one is more reliable method of encryption? Symmetric or asymmetric?
I think it's the better one is asymmetric, obviously.
Asymmetric. Because why? Because private key is responsible to decrypt the data. But private key is only with the receiver device. It is not on internet. It is not floating over the network, over the cloud. It is with the receiver only. Okay?
Yeah.
Okay, Jia, I have to end this class, but so we are done with chapter 1 and chapter 2. I will send you revision class of chapter 3, chapter 5 in some
Okay.
time. Okay, I will record it and I will send you. You will check those video. Again, I'm saying chapter 3, please learn von Neumann architecture. I will send you the video, revision video, okay? Chapter 5 is important. Chapter 6, start learning the... I will send you all the videos, okay? Recorded sessions.
Thank you so much.
Okay. Okay.
Bye. Yes.